values that does not fall within the within the uniformity, the normal distribution curve.
For example,
May I tell something?
yes, brother, please.
Thank you very much. The
Welcome.
outliers in another sense is outsiders. In a sample of data, these are the unusual or awkward data that is
Okay.
not that much interlinked between the overall data set.
Yeah.
So precisely, if we'll go for the determining the outliers, especially many other rules, but the two standards system to be identify the outliers. The first one is, that interquartile range. So just beyond the interquartile range, these are the outliers if the data set is not the normally distributed. If the data set is the normally distributed, then we can say that beyond the data, from the mean to 3 standard deviation plus and minus, these are the outliers. Thank you.
Okay. Yes.
I would like to add something more in
Yes.
outliers.
Please.
Can you allow me, the doctor?
Yes, please.
Basically, an outlier is an observation that lies an abnormal distance from other values in a random sample from a population. For example, a value that lies outside is much smaller or longer than most of the values obtained in a data set. For example, in the score of 25, 29, 3, 32, 85, 33, 27, 28. So in this data set, the 3 and 85 are basically the outliers, which are much away, either in the negative side, either in the positive side, or lies within a data set. Thank you.
Yes. How can we resolve these outliers? If somebody are outlying, how can we resolve it as a precaution, brother?
It,
You can do away with the outliers.
it basically depend upon the analyst, or basically in the census process, either author will decide it or analyst will decide it. Either it is considered normal or abnormal. If it is considered abnormal, so he or she can delete it from the data set, because it will disturb overall statistical process.
Mashallah.
Yeah,
Thank you very much.
may I supplement something, sir? May I
Yes,
supplement something?
yes, brother.
Yeah.
This is the
In a
platform to
data,
learn more.
yeah.
Yeah,
Thank you.
mashallah. Okay.
Thank you. In a data set, basically our mean will tell a lot of information, that is census and information. So in a data set, the outliers, what just the earlier speaker said about that, it's a totally unusual. It's a highly low or highly very, great in number, okay, in positive or negative side. In the random distribution of the normal, if you just say normal or non-normal distribution. So please, these outliers will just make the haphazards or nonsense or non-information about what the mean of the data sets is still about. So this is the total disturbance and totally, that dissolute the, make sense and information of all over our data. So when just we calculating our the mean. So the outliers are not getting well in our data set. So that's the main problem, okay? Because of the mean, the information from the all over data.
Okay. Just I would like to add with Brother Kamal. Thank you very much, Brother Kamal, for your nice explanation. Sometimes when we collect the data, practically what we observe, sometimes if we give it to the respondents for collecting the data, they take the questionnaire and just take it. They don't read what the statements are. Just give all 4, 4, 4, 4, all 3, 3, 3, 3 like this, all 5, 5 like this. Then these type of respondents influence our study. That's why we need to detect all of these all of these outliers to remove from our data set, because it is not sensible. These people just outlying and we put this result here. their response in our data set. So it will influence our study. That's why we need to exclude them from our data set. So what statistically what we need to do, we need to calculate who are those outliers. In through this software of SPSS, we can calculate, we can detect those outliers, those peoples. So
Question.
just a minute. And if you are in your if someone in your questionnaire, if only within the variable, suppose IQ, self-efficacy, or job satisfaction or performance, all these variables has some different items for measuring those variables. Now suppose job satisfaction has 6 items and performance has 7 items. So someone is lying with performance as well as satisfaction as well. They are outlying just without reading, just giving all are the same, or randomly they are doing it. So in that case it is called multivariate outliers. When more than one variables he is lying, then it is called multivariate outliers. If it is only a single variable within a single variable, then it is called univariate outliers. So to avoid or to detect this without putting after putting the response in our SPSS, then we can do this test. And for avoiding for not to give input the data, we have some preventive measures as well, like we can use a reverse coded item in the questionnaire, survey questionnaire. We can use the reverse coded item, by which we can easily detect this person did not read the statement properly, and you can just throw it out. So after that you can, and after as soon as we put the data, and if when we have the data set, then we can do the test of the test of Z score. By using the Z score, we can detect the univariate outliers, and by using the test of Mahalanobis distance, we can detect the multivariate outliers. So both of these outliers detection process we shall learn now. Is it okay now, sister? What's your question?
If we exclude any outlier from the data set, whether it will impact the skewness or kurtosis value?
It will change the skewness and kurtosis value as well.
Okay, thank you.
Sometimes due to the outliers, due to the extreme values and outliers, our data become non-parametric, non-normal.
Actually,
So
the squeeze is actually the skewness comes from the outlier.
Not necessarily. Not necessarily.
Exactly,
Brother.
not necessarily, but for most of the time.
No, brother. Most of the time, what happen in our practical life, our data is not normally distributed, and even if you are using the AMOS, structural equation modeling using AMOS, if your most of your I have seen most of the data is skewed. Most of the data is skewed most of the time. Otherwise, because our yes, most of the times I have seen when I use the AMOS, and I have seen the outlier, skewness and kurtosis, and I did the histogram. Then I have found many skewness. It doesn't matter actually. It doesn't matter.
Okay. Doctor, Assalamualaikum, Doctor. Can I ask a question?
Yes, please.
If let's say from the skewness and kurtosis result, our skewness and kurtosis show that our data is normal, we still need to test the outliers.
Yes, yes,
We
we have to
still.
delete the items. Yeah, observations. Yes.
Oh, even though our skewness and kurtosis is showed within the
Normal. Yes,
threshold.
yes, yes. The
Oh, okay.
more perfect data set you will find, and that would be ready for the. And sorry, actually, our for using the hours AMOS, we need our data is normally distributed, univariate normal as well as multivariate normal. Our data should be normal, univariately and multivariately. Okay. And how
Okay,
to
thank
do
you,
the
Doctor.
univariate outliers, detect the univariate outliers. So please go to the 6 number data set for univariate outliers. Please open this one, 6. Okay, everybody open the 6 number file, data set for univariate outliers. Open it, everybody. Yes, please go to the analyze, go to the descriptives, and go to the descriptives. So, and take all these items to the right side and just select the save standardized values as variable. Standardized values is known as Z score. Save standardized values. We are calculating the standardized values now. That is the Z score. Then OK. Everybody, please OK. It's OK. Now, if we go to our data set here, if you go down, see a new data set has created, a new data with Z score has been created with new variable Z was 1, Z score was 1 in level 1, Z was 4, all of these created. Z score of the data for each variables has been created. I can show you here. See Z score all. So we need to calculate either this Z score beyond our limit or not. Just I am telling you, if the Z score is within the 3.29, then we don't have any outliers. If it is exceeded 3.29, then we have the outliers, univariate outliers. Then we have to delete those observations. If this condition is for if your data set is or sample size is more than 80. If it is 80 or less than 80, in that case, if your Z score is plus minus 2.50, okay. So then we have the outliers. So what will we do now? We will go to the analyze again. This is the second step to calculate the minimum and maximum of the Z score. So how can we do it? Yes, please.
So when we go to the analyze and select a descriptive statistics and then descriptive again and select all, then what should I choose from descriptive options?
In the left side down, you will find Z score, Z standardized score. You will find there in the left side.
Can I share my screen again?
Just I am going to show you. You just here.
Select
this one.
That will
standardized values as variables. Just select this one, then OK. You got it?
No, sir.
Okay, just share your screen.
Yeah.
Saida Nasrin, you are from Pakistan?
No, sir, I'm from Bangladesh.
Okay.
So can you see my screen?
Yeah.
So here,
You just close this window, or the small window. Yes, this one. Yes, close this one. Yeah. Just select this one. The last. Okay. Go to analyze. Yes, descriptive. Yes, just select the save standardized values as variable. Left side. Left side.
Should I select all at first?
Yes. It is already selected. Okay.
Oh.
It is. Just click on reset, sister. You are confused.
Yeah.
Just
Yeah.
click on reset. Down.
Down. Okay. Yeah.
Reset.
Okay.
Okay. Take all this together. Just reset again. Just click the first one. Just select. Click on first one. The ways one. Just click the ways one. Click one and shift your press your shift button. And the last one, yes.
Don't know why.
You can control A.
Oh yes,
All
control
will
A
be
also
selected.
will be selected. Control A. There. Just control A in your keyboard. In your keyboard.
I know that. Just give me little time. I don't know why it's not one.
Control A. This Control A.
Control A. Yeah.
Yes. Yeah. Then take. Okay. Now, don't do anything. Just select. Save standardized values. Yes, this one. Okay. Then okay.
I'm so sorry, sir.
It's okay. Okay. Stop your sharing, screen share. Okay. The second step is go to analyze, go to descriptive statistics, and then go to the descriptives again. Then you will find like this, right? Windows like this. Everybody got this window? Just click on reset. Then this will remain the blank, the variables view. So go down and select all these Z score to the right side. Z score, all the Z scores of the variable. Sorry. Okay, take to the right side. Everybody has chosen this, all of this Z score.
Yes.
Okay, go to the options, select the minimum and maximum. This is not minimum and maximum Z score. Okay, then continue. Then okay. So this is the values that we obtain from here. See,
Doctor, sorry.
Yeah, please.
Excuse me, doctor. Just now you mentioned that if let's say our data set is more than 80, so the threshold will be 3.26. While let's say below
3.29.
To 9, okay.
Yes.
And then if let's say less than that is 2.5.
Yes.
Is it correct? Okay, thank you.
2.50.
2.5. Okay, thank you.
Welcome. You are from Malaysia,
Sir,
right,
is it
sister?
Sorry,
You
Doctor?
are from Malaysia?
Yes, I'm from Malaysia.
Okay. I was in
hello,
Malaysia.
sir? Is it from
Okay.
dataset 7, sir?
Yes.
Are you doing this for dataset 7, no, sir? Or 6?
Who is this, please?
Ayub Khan. So,
Okay.
hello? Hello, I'm audible, sir?
Yes, audible.
Sir, I just want to know that just now what you have done, sir, that is from dataset 6 or dataset 7, sir?
Dataset 6, brother.
Okay, okay, thanks.
Okay. So what the result we get here, this is the value of minimum minus 2.23, which is less than, since our number of observation is 477, so minimum, if it is beyond 3.29, then we have the issue. So here we don't have the issue. Suppose I am just showing you.
We can't see the screen, sir.
Okay, okay. Now you're watching my screen? Is it
No,
okay?
sir.
Huh?
No, sir.
Yes, we are watching.
I think, sister, you go to yeah. Where are you now?
Sorry, I missed this part, sir.
Okay, you will get the recording if you somebody miss it. Okay. So this is the result of minimum and maximum. Okay. If it is less than or if it is beyond minus 3.29, then we have to delete the observation. How we will detect that and how we will find that this one is like this? Suppose here if we check it, suppose this one weighs 1 and it has the problem in yeah, suppose 4 point something. What will we do then? Weighs 1, standard value, suppose weighs 1, suppose this one is 4, your standardized value came 4, then what we have to do? We have to delete this one, right? So in that case, what will we do? We will delete this number 4 one, this observation. Okay. If you find anyone, any observation which is beyond the value, beyond the rule of thumb, then in that case you have to delete those observations. Okay. Is it okay? Is it clear, everybody?
Yes, Doctor.
Yes, sir.
Doctor, excuse me.
Yes, please.
I'm sorry. Later, can you share with us the article that mentioned about this threshold so that we can attach in our report?
Okay. I shall.
Thank you, Doctor.
Okay.
Thank you.
I think in my no. No, I did not give you any. Okay, I shall give you the reference. No problem.
Thank you, Doctor.
Okay. So just now we shall calculate the multivariate outliers, and multivariate outliers can be detected through the Mahalanobis distance. and I think it is clear what is multivariate outliers. Is it okay, everybody, that I explained to you? And how to calculate this one? You will go to the analyze, you will go to the regression, then you will go to the linear. Then you have to select your variable, and you know univariate outliers been calculated through the items, but here multivariate outliers we calculate through the variables, and all these variables we compute the mean value, and within mean value of all the items of a particular variable. So we have to calculate those Mahalanobis distance from the variable mean value of the main variable. So how to do it? Let's check. Go to the 7 number file. Please open everybody. Data set for multivariate outliers. Okay. Open, everybody open it. Hello.
Yes, Doctor.
Yes, sir.
Yes, sir.
Please go to the analyze, go to regression and select the linear, second option, linear. Click on linear. Our dependent variable is perform, and we have 4 independent variable like ways, welfare, satisfaction and friends. Independent variable. Okay, if you cannot follow me or here, you can follow my slide I given to you. So you can select go to the linear regression and go to the save. From the save you can select the Mahalanobis, then continue, then okay, then you will I shall show you, no problem, how to do it. Go to the save and go to the select the Mahalanobis. It is the Mahalanobis distance, that's why. Everybody has selected this, then continue, then okay. So if we go to our data set, we will find these results. Okay, it is by default descending order, in descending order. If it is not, you just select it and just click the right button and show the descending. If it is like this, you can make it descending. Okay, so this is the Mahalanobis distance 1 it is showing. Now we have to calculate the probability. From the probability we will it has a 2-stage testing in the 2-stage procedure. So first of all we will calculate this one. Now we shall go to the analyze again. Sorry, we have to go to the transform. Everybody until here, have you done?
Yes.
Okay.
Yes, sir.
Yes, sir. Yes, sir.
Okay, then we have to go to the compute. This window came, right? Target variable, in the target variable, please write here probability. Probability. And here write here 1, then minus, if you go here, if you select here all, you will find file CDF chi-square. If you double click there, you will find this one. So 1 minus CDF chi-square in the bracket, you will take this Mahalanobis distance, comma 4. 4 is our independent variable. That's why we are giving 4 here. If your independent variable is 5, then you will get 5. If 6, 6. I think it is difficult for you. Can I show you once again?
Sure, sir.
Yes, sir.
Or you have
Yes,
done
sir.
it? Anybody?
No,
If
no,
we
yes.
do not have any issue, then I can proceed. Otherwise, I can show you once again.
Once more, sir.
Please do it once again, sir.
Okay, okay.
Sir.
We got this result. Everybody got this result?
Yes, we got it.
Yes, sir.
Mahalanobis 1. So, please go to the transform, go to the compute variable, in target variable, write here probability. Probability. We have to put a formula here, that is 1 minus CDF chi-square, and CDF chi-square, where you will get this? If you click here in all, you will find functions and special variables here. If you go down, then one of the options we will get as CDF chi-square. If you double click here, it will go there, CDF chi-square. And yes.
Number ni da yawa. Kawai dai ina yin gane in bi ta bin bidiyon kuma daga baya. Kin san lokacin ba mu idan da sallah ba, aka ce ayi launching a bubbuɗe.
Are you telling something, sister? Fatima?
Sister, please.
Fatima, Baba? Okay. Here, what will we do? Just you will double click here, Mahalanobis distance, that one that we have calculated, that one we are taking in our formula, then comma, then we will write number of your independent variables, that is 4. This is all about. Have you done?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Please proceed.
Okay. Thank you very much. Then click on OK. Okay. So, if we go to our data view, here it is not showing properly. What will we do? We will go to the variable view. Here we shall increase the number of the decimals up to 5. Please go to the variable view and increase the decimal number up to 5. If you go to the data view again, you will see here the value with decimals, with 5 decimals number. Here you will find if these values is less than 0.001, then it is an outlier, it is a multivariate outliers. Okay. If it is, I am showing here in our, if the value of probability less than 0.001, then the observations will count as multivariate outliers. So, what will we do then? We have to delete those items, those observations. So, how to do that? Sorry. sorry. Okay. So suppose this one is like this. This is less than 0.001, right? Are you agree? And this one also suppose less than 0.001, right? What will we do then? We have to delete those observation. Okay, like if you click the right button here, you can clear and you can make it clear like this. Then your data set will be free from the outliers. But one thing you have to remember, all of you, please, very important thing, when you are deleting any observations, you have to keep the note and what was the values. You will you will present. You have to report all of these observations number as well as what was their values, probability values. If you give in this way, then nobody will ever ask you that you did the wrong thing or how did you delete this, why you have deleted this. So you have to be very clear as a researcher why you are deleting your observations. You have to give the proper justification for keeping for giving the proper justification of deleting the observations. You have to report it properly. You have to give the item observation number as well as the probability and their Mahalanobis one result. If you report it like this, then nobody will ever ask you anything. You have to report it in your thesis. Okay, is it okay now how to delete the multivariate outliers from your data set?
Yes.
Okay. Now we shall go for the most important one, test of data reliability, Cronbach alpha. Okay, it is very important, all of you, and during our pilot study as well as after collecting the data as well, we need to check our data reliability.